In this chapter, we will learn how to configure DNS records so that your email server is recognized as an authentic one by internet. Before we configure DNS, we will learn what DNS is. DNS stands for Domain Name Service. Every domain on the internet has at least one corresponding DNS server. DNS service is a database with information about the machines belonging to a domain, such as the web server, the email server, the VoIP server, etc. This database is contained inside a server called the DNS server. For example, for a domain tech101.in, the DNS records could say that there is a machine named www.tech101.in, possibly used for a website. A machine named mailserver.tech101.in, used for emails, and a machine named video.tech101.in, possibly used to stream videos. Which DNS server contains the records for which domain can be obtained from the Whois database. As mentioned, DNS service is a database and contains records. There are 4 types of records that we should be aware of. First, we'll see the A record. A record is a record that says that a particular domain name represents a particular machine with a given IP address. For example, linolemachine.tech101.in represents 172.104.39.35. When you request linolemachine.tech101.in in any software, the above DNS record makes sure that the software connects to the machine with the IP 172.104.39.35. A records should be used sparingly because you may need to move your software from one machine to another. It is better to keep only one A record for every physical machine required in your domain. Next, we have the CNAME record. A CNAME record typically points to an A record. It may also point to another CNAME record, leading to a chain of records. For example, the name www.tech101.in points to linolemachine.tech101.in, which is an A record from the previous paragraph. You can create a CNAME record where m.tech101.in points to www.tech101.in, thus making one CNAME point to another one. When an application requests www.tech101.in, it is first resolved to linolemachine.tech101.in and then to 172.104.39.35. You can see that www.tech101.in and m.tech101.in are independent of the machine IP. They simply point to wherever linolemachine.tech101.in is pointing. This is useful if the same machine has multiple purposes. For example, if the same machine has the web server at www.tech101.in and email server at mail.tech101.in. If all the individual records were A records, then a change in machine and IP address will require you to change all those A records one by one. Next up is MX record. An MX record points to the machine which serves as the email server for a domain. We can have multiple MX records, one for each server that is an email server. The servers are picked in order of a number set as priority in MX record. For example, if mail.tech101.in is an MX record pointing to linolemachine.tech101.in, then all emails with the address @mail.tech101.in are sent to the email handling software on linotemachine.tech101.in. Finally, we have the TXT record. A TXT record is a record that holds plain text information. This information means nothing to the DNS server itself, but is meaningful to the application that requests and uses it. Here is why we should learn about DNS. You see, email servers use DNS records in specific ways. Here is a sequence. A software sends an email to john@mail.tech101.in from jane@gmail.com. This software connects to the Gmail's SMTP server to send the mail. Gmail server sees that the to field contains the domain mail.tech101.in. Gmail server sends a DNS request to its DNS server asking for the MX record for mail.tech101.in. The DNS server responds with another name, linodemachine.tech101.in. Gmail asks the DNS server for the IP address of linodemachine.tech101.in. DNS server returns an IP address such as 172.105.55.15. Gmail connects to the machine 172.105.55.15 and initiates SMTP communication to send the email. Given the above sequence, here is what we must configure in the DNS server used by our domain. An A record for the name mail.tech101.in that points to the IP address of the server where we configured postfix, which is 172.105.55.15. Since we will use email addresses with the suffix @mail.tech101.in, we will configure an MX record also named mail.tech101.in that points to the above A record. Note that both the records will have the name mail.tech101.in, but they are of different types, A and MX, and mean different things. I will explain more when we configure the records. A TXT record that contains SPF information. We will learn more about SPF while we configure that record. Alright, so we are ready to do some practicals. Unfortunately, this is where your method and mine may diverge. My domain, tech101.in, was purchased on GoDaddy.com, so that is the website I will use whenever I need to configure my DNS records. You may have purchased your domain from another provider, and thus your website and configuration screens will vary. But I urge you to stick with me despite the difference of provider. The user interface may be totally different, but the principles of DNS configuration are the same. The type of records that need to be configured are the same regardless of whichever domain provider you use. Here is what my GoDaddy DNS configuration screen looks like. First of all, we want to add an A record that points to the IP address of our email server. The name of the A record will be mail.tech101.in. Note that while I type the name on GoDaddy, I simply need to type mail instead of mail.tech101.in. The suffix tech101.in is understood since that is our root domain. Likewise, if you were to refer to the root domain itself, you simply need to type @. For example, if you were to purchase a root domain called alpha.com and want to configure an A record for alpha.com itself, you will simply use @ symbol in the name field. Such nomenclature is used by GoDaddy and a few other DNS providers, but not all of them. You may need to read the instructions specific to your provider. Our A record has been added. The name mail.tech101.in points to 172.105.55.15. It's time to add an MX record. since our emails will have the address of the form at mail.tech101.in. Our MX record should have the name mail.tech101.in. But again, we will simply type mail. GoDaddy will automatically expand it to mail.tech101.in internally. In our value field, we will write mail.tech101.in again. Now what is this? This refers to the A record that we configured above. Isn't this confusing? There are two records named mail.tech101.in and one of them has mail.tech101.in in both field name and value. What's going on? Let me clarify. The A record says that I want to name a machine with the IP address 172.105.55.15 as mail.tech101.in. I don't want to keep referring to it by its IP address all the time. Henceforth, I will use the name. The MX record, on the other hand, says something like this. For all emails sent to addresses with @mail.tech101.in, I want to use the machine mail.tech101.in. That is, the machine with the IP 172.105.55.15. The name in the MX record refers to the portion in the email address after the @ symbol, while the value of the record refers to a machine's name. Also note that the root domain is not assured in the value field. You must explicitly type the .tech101.in part. Why is that? Because it is possible for a server in one domain to act as the mail server for another. For example, for an address @alpha.com, it is possible to use a server such as mailer.beta.com. That's completely valid. Hence, you must specify the full name along with the root domain. Note the field name priority. It is possible for a domain to use more than one email server machine. Hence, we can create multiple MX records for a domain and rank them by priority. Lower the number, higher the chances of that server being used. Since we have only one postfix server in this course, we will use the value 1. Our MX record has been added. According to this record, all emails with the suffix @mail.tech101.in will be handled by the machine mail.tech101.in. Now let's focus on a type of record called SPF. What is SPF? SPF stands for Sender Policy Framework. In simple English, SPF does the following. Let's assume that Gmail receives an email from a sender, John, at mail.tech101.in. How can Gmail verify if the email was sent from the authentic mail server for the domain mail.tech101.in? Well, Gmail server has a start. It has the IP address of the server from where it receives the email. Next, Gmail requests a record from its DNS server. This record is a special type of record called SPF. This record verifies that the IP address indeed belongs to a server from the sender's domain. So here's what our SPF record looks like. Notice the special format used by the SPF record. You must create a record of the type txt and then create a value with 3 fields: v, mx, and -all or -all. The v field mentions the version of SPF used. We are using SPF 1 today. In future, more versions of SPF may be released and we will update the version accordingly. The MX field says that only the server that was configured by the MX record should be able to send emails on behalf of this domain. The -all field says that all emails that do not match the previous conditions should be blocked. In our case, we have only one rule, a rule that all emails from addresses @mail.tech101.in must be sent by the server that is configured in the MX record. That is the server with A record mail.tech101.in or IP 172.105.55.50. If this rule is broken, that is, the mail is not sent by that server, then that mail is rejected by the recipient. Our DNS records have been created. How do we check that these name changes are saved and are ready for use by the rest of Internet? For that, we have a handy website named dnschecker.org. On this website, we can check if sample DNS servers from around the world got hold of our records. How can they? Well, all DNS servers in the world communicate with each other, either directly or through a chain of hierarchy. When someone adds new records to a DNS server, they announce that the records have been added. Other DNS servers in the vicinity receive the announcement and forward it onward until all DNS servers in the world receive the new records. The process is called DNS propagation. In fact, you will see the word as part of the title above the map, a propagation map. This website checks whether sample DNS servers from every continent have received the propagation. On DNS Checker, one can check for any type of DNS records, be it A, CNAME, MX or TXT, and a bunch more. Let's check if our A record mail.tech101.in has been propagated. Yes, it was. You can see right here that this DNS server from the US is able to resolve the IP address that we had entered for the record. Let's check the MX record now. It was for mail.tech101.in. There you go. You can see that a line shows 1:mail.tech101.in. The part after the colon is clear. It shows the name of the A record to which this MX record points. In other words, to the machine that will handle emails for the domain mail.tech101.in. But what about the number before the colon? Well, that's the priority of this server. Remember that we had set a priority of 1 for this MX record while creating it. Finally, let's verify the SPF record. For that, we need to check for the presence of a TXT record for the domain mail.tech101.in. And there we go. You can see that the line that sets the SPF record for our mail.tech101.in domain. Here it is. How can we check if this SPF record is valid? Fortunately, we have an online tool named mxtoolbox.com. When you click on the More section on this website, you come across a page with several tools. One of them is the SPF checker, also labeled Sender Policy Framework. All you need to do is to type your domain name here and click the arrow. Here you have an analysis of your SPF record. It shows that your record is valid. It also lists the meaning of each component that you configured inside the SPF record. This looks good. And there, we have successfully configured DNS records for use with our email server. On one hand, we have the DNS records which will be used by the internet to find our server and also to validate its authenticity. On the other hand, we have postfix installed on our server so that mails can be sent and received. Let's use mailtester.com to measure our mail deliverability once again. Have we improved our score? Let's start. From here, I go to the console for send mail. The score is way higher this time, so a definite improvement. What about sending an email to Gmail? Will Gmail treat this mail more kindly now that DNS settings are in place? This time, we did not get an error code 550, but rather a code 250, which means success. Gmail accepted our email without rejecting communication with our server. This is because Gmail was able to validate the authenticity of our server as a valid machine to handle emails on behalf of the domain mail.tech101.in, which it found in the from address. Still, was the mail welcomed by Gmail and shown in inbox? The answer is no. The mail isn't sitting in our inbox, but we did see in the logs that Gmail hadn't rejected it. The mail hadn't bounced, so let's check if Gmail is keeping it in a folder other than inbox. Spam, perhaps? And there it is, sitting in spam. A mail from Devon. Let's expand the email to see what it contains. The body of the email is exactly what we typed in sendmail, so that's good news for us. One thing you'll notice is that Gmail isn't happy with the security. We sent the email from a server which isn't SSL enabled. The chances of someone snooping the email on the way and modifying its content is very high. Another security we need is something called DKIM, which prevents changes to the header and the body of the email. We'll fix both in the chapter on security at the end of the course. While not our best result, we still have progress. In the last chapter, your email was rejected by the Gmail server, but now it's accepted, though marked as spam. For now, assume that outgoing mails are working on mail.tech101.in. Let us check incoming mails for a change. Let's try an email address such as john@mail.tech101.in. We have sent our sample email. Now let's quickly go to the console where we have postfix logs open. There comes the log. So Gmail was able to find our server via the DNS MX record, connect to the server, and shoot the email. However, we have a problem from our end. Notice that the error says that the address is not found. That's natural. Remember that in the chapter on MySQL, we had configured two users named Henry and Paula. There was no John in our records. Moreover, we are yet to configure postfix to use our MySQL database to find users. So whichever address, real or imagined, we send an email to, the address would be found. You can also see the result in your Gmail inbox. Here is the bounced email. But in summary, you have made significant progress in furthering your self-hosted email. Your postfix server is able to communicate and exchange emails with other email servers on the internet. Isn't that a matter to be happy about? See you in the next chapter where we will configure postfix to use our database.